VoIP networks, but you may assess VoIP protocols as part of the assessment. You don't want to ignore it. I'm not saying you ignore it entirely in the assessment, but there's enough information out there to get the stuff that you need in order to do this effectively. So the basic approach is to look at the authentication methods, how they actually work. So the guys earlier today demonstrated, sniffing passwords, but we're all familiar with how that can be done. And then you look at unauthenticated attacks, then attacks once you have authentication, what users can do when they're in there and so on, and the encryption and signing options that you have with the system. Probably what receives the least focus, other than the entry point issue, is the support protocols that are involved in a voice over IP system. So voice over IP has a lot of dependencies. We've seen that we have operating systems and we have databases and firewalls and so on. We also have things like TFTP for configuring the Cisco phones, DHCP to set the systems up in the first place, DNS so that they can talk to other systems within the network infrastructure. And these protocols all have their own issues that we can find, like misconfigured DNS where you can get zone transfers, and TFTP unauthenticated and unencrypted, and age-old issues. But what these do with VoIP is they increase the risk because you have all of these different components, and whenever you have complexity, you have more scope for vulnerability. You have more issues that can come up, and you just have more avenue for attack. So when doing a VoIP assessment, you want to also assess this infrastructure at the same time. You want to have a look at it and make sure that it supports the VoIP system properly and it's configured appropriately to support the systems in a nice, secure way, not leave your voice systems open to attack. So if you can accomplish eavesdropping on the voice over IP connection within the internal network, then that's not generally a problem with the VoIP system itself. That's a problem with the network. Why is an attacker running a sniffer on the internal network in the first place? How did he get in? What's he doing there? So we'll look at the case study of Asterisk and quickly go through how you would assess a system such as this one. So the reason we choose Asterisk is because a lot of you guys will be familiar with it because it's it's free software, it's popular. You don't need much hardware to get it up and running. You can set it up just on a standard PC. You don't have to plug in the GM's cards if you don't want to. And it's open source, so you can go beyond some of the methodologies and you can look further at the source code. You don't have to fuzz if you have source code available. You can fuzz alongside it, but you can also look at the code and see what it's doing and find vulnerabilities. Yeah, we don't want to click end. So there's a sneak preview of what's coming up. The operating platform for Asterisk. I don't know if any of you guys pay attention to the Asterisk mailing list and so on, but one of the most common questions is, what ports to open for RTP? It's not working. Why am I getting the call connected but I'm not getting any sound? And they don't understand the complexities of configuring the firewall properly. So this is yet another area where they may open up the firewall to allow the access, but make it too wide and too open, and let more stuff into the network than they really should do. And then you can look at the basic DNS problems in TCP and UDP and so on. Asterisk has suffered from a number of denial of service vulnerabilities that can be perpetrated through UDP. The operating systems runs on Linux, which is it's not the most secure operating system in the world. It's as good as the other operating systems. They all have vulnerabilities. And if you have that system installed and you have an Asterisk system installed, then the vulnerabilities on that system relate to your Asterisk installation as well, and they increase the risk. You can also run Asterisk on Windows, but it's a bit of a hobby project, and it's not very stable, so it's not commonly used. So you have to keep these systems patched, you have to look after them and so on. You have the database servers. Asterisk it integrates with Sugar CRM quite well. You have like FreePBX and Trixbox that add extra support, make it easier to configure. So you can configure Asterisk with a nice web-based interface, which can help some people because it's a complicated system. If you look at the flat database, flat file format that's used to configure Asterisk systems, there's a lot of information in there, and you have to read through the dial plans. And if you haven't charted these and documented them, they can be quite hard to follow. So these things make it a little bit easier. But they also have vulnerabilities. So we found vulnerabilities in Trixbox and FreePBX. We've found vulnerabilities in VOIP as well. Haven't looked at Asterisk now, but it's on a list. So some of the vulnerabilities within Asterisk. These are some of the denial of service vulnerabilities that we spoke about earlier. And if you have a look at them, you can see that they're almost entirely within the implementations of the VoIP protocols. So you have SIP and IX, and this is where most of the vulnerabilities are, and then you have the management interface ones as well. And that can be a major issue. A lot of these vulnerabilities are really quite simple. They're a couple of packets, they're one packet, and you've knocked the system over, which is not good for a system that needs a relatively high service level. There's also a number of code execution vulnerabilities in Asterisk, and other VoIP systems as well, but the case study of Asterisk shows them. And some of these are really brain-dead vulnerabilities. There's so much research going into protocols and so on with VoIP systems. You'd think that by this point they would maybe cover the basics. So, what's this? Does anyone recognize that? Someone's mumbling, but I can't hear what it is. That's a buffer overflow. It's probably one of the most basic examples of a buffer overflow you'll come across. Some user input is being stuck into some variable without validation. And I haven't hidden any code here. There's no validation beyond that. That really is user input gets straight to this point in the system, and you get remote code execution. So this wasn't found. This wasn't found like 10 years ago. This wasn't found 15 years ago when buffer overflows were making the news. This was found a couple of months ago in the SIP handler for Asterisk. So within a protocol that has its own problems, you have the voice over IP developers putting in problems by not understanding basic security. And this is across the board. This is why all these SIP clients, all these PBXs have so many vulnerabilities coming around. These guys are spending so much time understanding these complicated protocols. I don't know if any of you have looked at the specifications for free-to-free or specifications for SIP. Not easy to follow. Very difficult. Throughout the Asterisk source code, there's complaints about how hard the RFC for SIP is to understand and interpret and use properly. So, the configuration within Asterisk, we were looking at some of these things earlier. Like I said, the configuration files for Asterisk, there's quite a few of them. They're scattered all over the place, and you can stick information all around within these. And if you don't document what's there, you can make a lot of very basic mistakes. And one of the most basic, which is the default within the Trixbox installation, is to have ChanSpy or Mix Monitor available to any context. And that can be a major issue if someone can just call up that number and start monitoring the conversations and stuff that are going on. They can abuse these systems quite readily. So the bad dial plan logic and so on makes itself very, very evident when you have such a complicated system to put together. The accounting and billing systems that are related to Asterisk, they all have their own security problems that, like Sugar CRM has had a number of vulnerabilities in it as well. So when you take all these systems together and build up your infrastructure for voice over IP, you can see there's a lot of avenue for attack there. Way far, far more than just the protocols and implementations. There's a lot of bugs that you can have a look at, a lot of things to be found with a bit of research. So we have the encryption options, and earlier on there was little response to the question on encryption. It's just not, it's not readily available, which is why Philip Zimmermann has to, develop software in order to plug in and make this easier for people to use. If you make encryption easy and capable of plugging into the systems that people have, like PGP, work for email, then people are going to use it. They're going to communicate securely if it's easy to set up, if it's default, and if it's built into the system. And there's good capabilities there. And so we've seen the vulnerabilities within the implementations of the protocols. We've seen that it's fairly complicated to configure, and the developers make a lot of assumptions based on the RFCs and specifications for protocols, because they're not quite sure how to handle these things. There's quite a few messages in SIP that are repeated, and you have like different messages that could mean the same thing. It's like HTTP, you have like codes at the beginning for each message, but the definition within the RFC is not terribly clear, so it becomes up to the individual implementer to deal with these issues. So the practice safe convergence was a quote that one of my friends said, which I thought was pretty good, and covered the segregation issue that we have. When you converge networks together, do it in a secure way. Try and make sure that you segregate where you can, and you make it nice and simple. You break it down, you have front end, back end, or so on. Or if you have multiple servers and gateways, you can split them out and secure the links in between these. Check the VoIP products themselves for vulnerabilities. Look into them. They have really simple vulnerabilities going on, so get rid of all of that. Remove these from your systems. Make sure that the systems that you use yourself are free from these as much as possible. And when looking at these systems, don't scan them. Don't run vulnerability scanners and leave it at that. Go into more detail on them. Have a good look at these configuration files. Do an audit. An audit's not a scan. An audit is looking at the configuration files, seeing how this is put together, and making sure that the policies that the business have implemented relate to how the system is set up, and that the setup of the VoIP system doesn't introduce vulnerabilities to the business processes within the organization. So, more information on this. VoIPSA, who do quite a fair bit of research. Again, a lot of focus on the protocols there, but they have a pretty good threat taxonomy. Has some random strange things in there, like extortion. I don't know why that's a VoIP-specific issue. It's a general communications issue. Then you have the NIST, US government information. VoIP info, they're a good source of information, specifically relating to Asterisk, I suppose, but they do have some security information in there, and what your options are for encryption and so on. And then the OSS, TMM, are currently developing a testing methodology for VoIP. It's when version 3 of the manual comes out, then the VoIP component should be added to it at that point. And that concludes our talk for today. So, does anyone have any questions about the content of the talk, or specific issues that they have with voice over IP systems? No questions? Okay, well, yeah. So, like using VoIP over like IPsec or VPN? Yeah, there's not a lot of research required. The main issue that you'll come across when you do that is latency. If you've got some of these encryption options,